I've been talking for some time now about designing and making a new clock and showing the process of both the design and making all the parts in a series of YouTube videos. I'd also really like to make the plans available to anybody else that wants to make this clock. So if you're interested, please let me know, and if there's enough interest, I'll start a Patreon channel and post the plans there. So I'd like to start with an overview of describing what this clock is about and the reason for its design. There was always a certain amount of frustration in the building of my previous clock, because although it had many of the features that should make it an accurate clock, it was always compromised by the use of a compound pendulum. So in this clock, my number one aim is to make a very accurate timepiece. And to try and achieve this aim, I'm going to use John Harrison's techniques of balancing all the atmospheric conditions and playing one off against the other. These methods were described so eloquently in the book Harrison Decoded. And Martin Burgess used these methods to great effect in his world record breaking Clock B. My second aim for this clock is that it should have a sculptural feel to it and be of a small enough size that it will be unobtrusive hanging on a wall in any house. This view of the clock shows it face on, and the height is about 700 millimeters and the width 500. And this small size is made possible by the use of a 2/3 seconds beating pendulum, which is approximately 440 millimeters long, as opposed to the seconds beating pendulum on clock B, which is a shade under a meter long. Unfortunately, this breaks one of Harrison's main rules, which is to have a long pendulum. So this may have an effect on the ultimate timekeeping we can expect out of this clock. But that's all part of the experimental nature of this project. So far, you've been watching my efforts at making a 3D CAD model of the clock, and I'm now going to work on making a 3D printed version. And this will hopefully function and will help with the visualization, and then we can make changes to the clock as we go along. So I finally assembled the 3D printed model, and I've got the first ticks out of it, which is really exciting. It's not brilliant, but it does work. The engagement of the pallets on the escape wheel is pretty terrible, but I can just about get away with it. But bearing in mind the pallets are made of plastic, 3D printed plastic, and so is the escape wheel. It's pretty amazing that it actually works at all. So I've got the clock set up in my workshop, and I've modified the pallets on the grasshopper a bit. I've just filed down the ends of the plastic pallets so they seem to be engaging a bit better. I've made a pair of hands, and I've changed the spring in the Harrison maintaining power because that really wasn't working before, and I want to see if it is going to work. There was a misstep in the grasshopper, so I want to see if it is going to work, and so I'm going to wind the clock and we'll see if it actually stops or not while I'm winding it. There, here goes. So I'm happy with that test. The grasshopper has kept going, and so obviously the maintaining power is doing exactly what it's meant to do. So I just wanted to talk a little bit about the layout of the clock. I've got the clock currently mounted in these acrylic plates, and that's just so I can really visualize what's going on with the wheel work. And I know aesthetics are fairly subjective, but I wanted to base the design of the clock around the two great wheels, which I know are going to be a bit of a nightmare to cross out. So in the actual clock, I think I'm going to use either brass or steel plates, and I think the decorative wheels, the two great wheels and the intermediate wheel, I think I'll have sitting in front of the front plate. I think Martin Burgess did this brilliantly on clock B, so you can really see the form of these major wheels. I'm also toying with the idea of having the escape wheel, the remontoire and the grasshopper set in glass plates so that you can see very clearly what's going on, and you should also be able to see the suspension spring through the glass. So I'm now going to take you on a quick tour of the clock and explain its layout. The first thing you'll notice is that I haven't yet designed the remontoire. So in the next video I will show how this is incorporated into the design. One of the great things about making a model out of 3D printed parts is that they're incredibly easy to change, and you get a really good visual sense of what the overall clock is going to look like. So starting at the top of the clock, we've got the grasshopper acting on a 90-tooth escape wheel which turns once in 2 minutes, and that's geared with a 5-to-1 reduction to the intermediate wheel, which turns once every 10 minutes. And that's connected to the minute wheel via a 6-to-1 reduction. And then I'm going to turn the clock around, hopefully without stopping it, and I will show you how that's connected to the drive wheel. So the hour wheel is connected to the drive wheel via this quite large roller pinion, and there's a 2-to-1 reduction ratio there, and that's connected directly to the Harrison maintaining power and the differential barrel that you can see here. And then if I turn the clock around further, you can see it from the other side. So now I've turned the clock around a bit, you can see the hour wheel here, and that's connected via this 6-to-1 reduction pinion here, which is on a coaxial axle with the intermediate wheel that I showed you to start with. So I hope that's given a decent overview of where I'm up to with the clock so far, and in the next video I hope that I will have incorporated the remontoire and thought more about the front and back clock plates and what they're going to be made of. So if you've made it this far, thank you very much for watching, and I hope to see you next time. And also, if anyone is interested in making this clock and would like a set of plans, could you let me know in either the comments or via an email? And if there's enough interest, I will post the plans on a Patreon channel. Thank you.